So you are welcome to session 9, cognitive learning. Cognitive learning. Having discussed the previous learning types, let's move on to look at cognitive learning. So this is just to let you understand that it's not all learning type that is due to operant and classical condition, observational learning. There are others that require more mental elements. So humans and even animals learn sometimes, and this includes large cognitive and mental dimensions because we are affected by mental images, expectations, perceptions, and so on as we interact with the environment. So in this section, we look at discussing the key features of cognitive learning. We then look at insight learning and latent learning and how these are applied in our everyday life situations. So we expect that you, the students, will be in a position to, after discussing this session, be able to define and explain the types of cognitive learning and demonstrate knowledge of the types of cognitive learning and further understand the processes and the application of cognitive learning theories in our everyday life situations. So to help us do this, we have 3 main topics where we look at the definition and the types of learning, cognitive learning, and then the application of cognitive learning theories. Yes, the relevant text chapters and reading materials are available on Sakai. We put it on Sakai for you to refer to, add some further details on it. So let's first look at the definition and the types. What is cognitive learning? This refers to the understanding, knowing, anticipating, and making use of information-rich higher mental processes. This is found in Kuhn 2001. So at the core of the cognitive approach is a belief in mental representation. That is the coding of external events so they are retrievable in an internal form. So there are types that we'll be looking at. There are different types, but we'll focus our attention on cognitive maps, latent learning, and insight learning in this session. So let's look at some key individuals and their contributions, bringing out whatever they did to make cognitive learning very vibrant. Now, so Tolman, Edward C. Tolman, developed what is called the conception of cognitive map, place learning, and latent learning theory. He believed that learning occurred through mental activity. So we want to look at the experiments and the implications for the theory of cognitive learning. So Tolman did an experiment using the maze and rats. So in his experiment, he set up a complicated maze which involved several different sets of T-junctions, as you can see in this diagram. So in one of his key experiments, he used 3 groups of rats. So one group was given food at the end as reward. The second group was not given any reward at all, but the rats were placed in the maze and they were allowed to play in it as often as the first group. Then the third group was not given a reward for the first 10 days, and then later on rewarded from the 11th day. And this brings about several kinds of results. So he found the average number of errors made by each group, and that is what you're going to be looking at now. So group 1 made consistently fewer and fewer errors with each occasion that they were placed in the maze. So by day 17, they were completing the maze very rapidly with an average of only 2 mistakes per trial. With group 2, they did not show any particular improvement. And by day 17, they were making an average of about 6 errors per trial, if you look at it compared to group 1. Now the third group, they showed no noticeable improvement initially until the point where Tolman began rewarding them. So within a couple of days, they were performing as well as the rest in the group 1. By day 17, their average number of errors was only just above 1 per trial. So it tells us something from this. So the explanation that was given was that the rats had what is called a cognitive map, or mental images of the maze. So what happens, let's look at the third group. The third group of rats also demonstrated that there is what is called latent learning, because they've been learning about the maze while they explored, but they were not given reward. Because when there was the need and they were given the reward, that's when they kind of showed that they really learned it. Therefore, when needed to get the reward, they used their experiment of the maze, which formed their mental image, and were able to perform very well, just as the group 1. Just as the group 1. So now let's look at cognitive maps. Cognitive maps are mental representation of the spatial layout of one's environment. Everybody has cognitive maps. You might want to even direct your friend to your house, because you know where your house is located by virtue of you having the cognitive maps. They form the basis for place learning. Using your understanding of, or using the mental image, mental pictures that you have about the location, you are able to give directions to such places. All right, so latent learning. Latent learning can also be looked at. It shows that learning occurs, but is not apparent until there is an incentive to demonstrate it. Some books and some scholars refer to this type of learning as hidden learning, as learning which is hidden. Sometimes you may not know it is even there until there is some form of incentive for you to bring that learning out, whatever you learn out. That is when you will then bring it out. So this type of learning emphasizes, that is latent learning, emphasizes that it does not take reinforcement to learn behavior. However, it takes reinforcement for a learned behavior to be exhibited. That is latent learning, hidden learning. You could see that with the rats in group 3 of the maze experiment. They were learning. They were going to the maze with a reward until the latter part, when they were given the rewards, they were able to quickly pick up and even performing just as the group 1, which were given reinforcement throughout the experiment. It tells us that learning can take place, but sometimes unknown to us. Learning can take place hidden until there is incentive for it to be exhibited. That is when we demonstrate that. So with that, we've come to the end of topic 1. Let's look at the next topic, topic 2, which is a continuation of what we started with topic 1. We're going to continue with the types of cognitive learning. So now we're looking at insight learning. Insight learning theorized by Wolfgang Kohler, a German psychologist. It is a sudden discovery or understanding of the relationship in a problem that can be discovered. A sudden discovery. Some will want to describe it as aha learning, something that is found all of a sudden. Something that is discovered all of a sudden. I have found it. That kind of situation. So experiments were used as usual to establish or to get to theorize the concept of insight learning. So in one experiment, Kohler used chimpanzees to investigate insight learning. So with this experiment, a chimpanzee was placed in a cage with 2 short sticks and banana placed outside. Of course, chimpanzee who want to take the banana, they tried, they couldn't get the banana. With the 2 sticks the 2 sticks lying or placed in the cage, it finally identified that it could use the sticks, fix one into the other, and use it to get the length that would be needed to pull the banana. And it did that and ate it. So it was a sudden kind of discovery by the chimpanzee that it could engage in this. So this is an example of insight learning. This is the picture that shows the chimpanzee fixing the 2 sticks together. Who taught the chimpanzee how to do this? What kind of reinforcement was it? So it tells you mental kind of operations, or all of a sudden this coming up with the chimpanzee was able to get these sticks together and then getting the size needed. In another experiment, a group of chimpanzees put in a room with some boxes around, and there was a bunch of banana hanging at the ceiling. They tried to get the banana, but they couldn't. Finally, with the boxes, they put one on top of the other and got the banana, which was hanged at the ceiling. So let's look at the pictures here. So you see these chimpanzees, one sitting on the box and holding another box, and another chimpanzee climbing on top so that he could get the banana. This is a discovery kind of learning, insight learning. So you want to ask yourself, what principle underlie this type of learning? Cognitive psychologists believe that insight learning involves a perceptual reorganization of information, the ability to discover new relationship among familiar elements around you, like the chimpanzee and the 2 sticks. You found out there is a relationship between the 2 sticks. The 2 sticks are familiar, but there is something else that can be done. So reorganizing them, he was able to put one stick into the other, getting the length needed to pull the banana and use it. The same way with the boxes. So based on these studies, Kohler concludes that insight learning depends on the internal relationships in the problem to be solved, and whether the task is within the cognitive capacity of the organism. So this is very, very interesting, that sometimes with a kind of cognitive operations, we're kind of reorganizing the information, perceptual reorganization of information, you are able to discover something. You can solve problems. You can solve problems which you didn't have the skills initially, but you can solve problems if you take time to look at them again and try to discover any new relationship. With this, we've come to the end of second topic. Let's now look at the last topic for this session, which is the application of cognitive learning theories in our settings. Let's first look at in education. In education, students learn to use cognitive maps so they can remember their classroom scenes, portions of their notes, etc., in examination conditions. Sometimes students remember the exact location or the exact point where a lecturer explained a point. When they're in the exams hall, they're able to picture how the lecturer was saying it, and in a way, they are able to remember the point they are trying to make and then respond with that, and they get the correct marks. Relying on insight learning, you can see interconnectedness and relationship in certain courses and concepts. This will allow you as students to answer questions by making inferences. For instance, as a student, you have to store and organize knowledge in your memory such that knowledge is conceptually linked to other pieces, and you are able to get the picture well and provide the needed responses. So in education, we use a lot of cognitive learning concepts or theories. The same way in organizations, in industries, there are several ways we can look at it. Let's take first taxi drivers. They know places, several places. Sometimes you ask yourself, how are they able to get that? They rely on cognitive maps. They rely on cognitive maps. So it helps them to locate places. So once you mention you're going to a particular location, they remember they've been there before, or they know an area around that, and they are able to quickly take you there with relative ease. Then we have air pilots and other navigational professions. They need cognitive maps to really operate. And several other work settings, even at home, in our places of interactions, markets, and so on, people are able to rely on cognitive learning theories to really function effectively. And with this, we've come to the end of this session. Let's prepare ourselves for the next session. Thank you very much.